Hello everyone, I am CA Swapnil Rege. I am a member in industry with more than 16 years of work experience in the oil and gas sector. My topic today for Capstone project is a data analytics platform, something which is related closely to the petroleum sector. This data analytics platform connects with Open Government Database Portal through an API integration. This helps to pull datasets through an API call, whereby this data can be used to create interactive dashboards. These dashboards offer very valuable data-driven insights to senior management professionals of any company in oil and gas for future strategy, operational planning, or long-term vision. Now this video is divided into 4 parts. Part 1, I will be covering the problem statement and the use case for this Capstone project. Part 2, I will cover the solution architecture and a crisp demo of the project. In part 3, I will attempt to answer the question of where is AI in this product. I will touch upon the tools of AI used for development of this Capstone, like Google Antigravity and the Python libraries, etc. in this part. Finally, in the last part, that is part 4, I will map the areas of my Capstone project with the course modules to prove how the learnings of AICA Level 2 helped me build this Capstone data analytics solution. So guys, hang on and let's start the journey. So guys, let's get started with part 1. The Capstone use case tries to address 2 most important problems that senior executives and MIS professionals in oil and gas industry face. First problem is fetching the right kind of data sets. And the second is generating insights from the available data. So for fetching the data, I have used Open Government Data Portal, which is part of Digital India initiative. For understanding the power of OGD portal, I urge you to go through a link of a YouTube video on Open Government Database Portal, which is given in the description below. For my Capstone, OGD portal gave me the superpower to fetch data through APIs. Just imagine how difficult it is to keep searching website of Ministry of Petroleum and Natural Gas for industry specific data every day. Now I have addressed this by creating something called API Data Manager using Python. Second problem is generating insights from available data. Here I have leveraged the power of Python libraries like Streamlit, Plotly, Altair, GeoPandas and Folium, which you can see on the screen. This helped me create vibrant and appealing dashboards which can be delivered to the users through the presentation layer. So without this solution, companies will be spending substantial amount of manpower and follow-up time for fetching data. Further, they will also be using old school and outdated solutions like spreadsheets to generate data insights. See, interactive dashboards will always win over spreadsheets due to the popular saying, a picture is worth 1,000 words. My Capstone project also stands testimony to the point that we can leverage Python to beat traditional BI solutions already available in the market. In level 2, we were taught about agentic AI and integrated development platforms. My use case, which is closely linked with dashboards, has been built using Antigravity along with Google Gemini Pro and of course the Python code with real-life application of agentic AI coding for generating insightful dashboards. So guys, coming to part 2, that is the solution architecture and product demo. Let me show you a small PowerPoint slide which I have prepared to explain the solution architecture behind this product. See, this product uses data available in public domain which has been published officially by Ministry of Petroleum and Natural Gas. The system architecture has 4 components. 1. API data manager. Second, a data warehouse which stores the data. Third, a Python coding and application layer which you can see in the architecture diagram. And finally, fourth, the presentation and reporting layer which the user sees when he sees the interactive dashboards. So if you observe the architecture diagram, you can see data is getting fetched using API data manager. It is entering the database and it is getting processed by the application layer. Finally, it is getting displayed on the front end for the consumption of the end users. So guys, let us go to the data analytics platform for a crisp demo. In order to save time and hassles, I have already logged in into the Open Government Database portal. As we do with most of the data analytics solutions, I have developed a landing page which I will show you as part of this solutions demo. So this is the Streamlit front end, the Streamlit browser you can call, and this is the landing page. On the landing page, we will click on the API data manager and it will open the drop downs of API data manager, which will connect us with multiple APIs of the Open Government Database portal. So you can see on the screen the API Data Manager. Let me go to the Open Government Database portal. Here I will generate the API key, which is the connecting link between OGD portal and my solution. I will copy the key. You can see on the screen it is copied, and I will go paste it in the API Data Manager. Then I will press the test connection to ensure that the connection between API Data Manager and Government Database is established. You can see I have got the message, connection successful, API key is valid. Now before extracting data, let me show you the folder status. If you see currently, the folder in the data warehouse for crude processed data is empty. What I have done is I have created a folder structure for the data output of each API call in a proper order. The first one that we are trying is crude processed data. And if you see, this folder currently is empty. Now let's try our API by triggering an API call and see if we can fetch data here. Since the API connection is already established, I will directly go to the Data Manager. In the drop down, I will select crude processed data. The resource ID auto populates through a logic. Then I will select one very important parameter, that is the output format of the data. I am selecting the CSV output format. And finally, I will press this button, fetch collection data. There you go. You can see certain logs have been generated. I have got the message fetching collection data for crude processed. And finally, success, data saved to so and so path. Now let us check in the data folder whether we can see some data. There you go. You have a folder automatically created by the system with the trace of today's date, month and year in DDMMYY format, and the trace of time in hours, minutes and seconds. Inside this folder, you can see a CSV output, which is nothing but the data which we procured from the Open Government Database portal. Isn't this fantastic? Now, let me show you another key feature of API Data Manager that we have given. I have also created the facility to schedule an API auto extract job. Now, we can put single API or multiple APIs on auto extraction mode by using this API auto extract job schedule configuration. The only thing you have to do is you have to set this frequency value. You have to set the maximum number of runs, and you have to set frequency units, which is minutes or hours. So based on whatever you select here, if you select minutes, the API will trigger in couple of minutes. If you select hours, the API will trigger in couple of hours. So this is what I have in the API Data Manager. Now let's go to the data presentation and the reporting layer of the analytics solution which I have developed. If you see from the landing page, I have divided the data presentation layer into two parts. Part 1 is analytics dashboard for crude and LNG trade data. Part 2 is analytics dashboard for refining. We'll first focus on the dashboard for refining. So guys, after giving an overview of the API Data Manager, here we are to have a crisp overview of the presentation layer. As shown in the earlier parts of the video, I have already used the API Data Manager to extract relevant data sets from the Open Government Database portal. Now let's quickly head to the portal landing page. For that, you have to click a fire icon which will lead you to the landing page of this Petroleum Data Analytics Solution. Once we are on the landing page, we will click the dashboard for refining section. Here we go. We have this analytics dashboard of refining. I will click on the tile and it will open another tab in the Streamlit to display the entire dashboard showing interactive tiles based on the crude processed and refining capacity data that we had extracted from Open Government Database portal. If you see, we have a wonderful backdrop of refinery. This is an actual refinery crude distillation unit picture that has been set up to give that look and feel of oil and gas industry. So guys, here we go. We have a sidebar panel here which shows the dashboard menu. This sidebar panel can be switched on and off based on user requirement. In this sidebar panel, we have a host of radio buttons. We will go through the radio buttons one by one. Each radio button represents a dashboard page. You have to click on the radio button and press Launch Dashboard to enable the display of the dashboard. So I'll click on India map crude processed and I pressed on Launch Dashboard. There we go. So we have got the dashboard here. Now this is actually divided into two tiles. The first is the map of the crude processed by refineries all over India. So we have used a library called GeoJSON to plot the latitude and longitudes of each of the 22 refineries in India. If you go and hover the mouse on mouse pointer, you can see the refinery name, the quantity of crude processed in metric tons, and the year. So you can navigate over each state in the country to see how the data gets displayed in a call out box. Now this is the beauty of GeoJSON, that it can plot the data wonderfully and show it on the map of country India. We have given the input parameter, the selection parameter of financial year. So the data is available for almost last 8 to 9 financial years. Let us go and select the data for financial year 22-23. There you go. Data is getting refreshed. And the dashboard has reloaded. Now if you see, I have given a toolbar to view this dashboard in a full screen mode. Zoom in, zoom out. Let us try the full screen option. There you go. The view in full screen is even more attractive. You can see on mouse hover, once again the data is visible. So this is the data of crude processed by each and every refinery of the 22 refineries in India. Let me take you through the installed capacity. It's a similar kind of GeoJSON report. So this is basically the magic of the Python libraries converted into interactive dashboards. Let's quickly go to the next radio button, that is GRM comparison. So GRM basically means gross refining margins. This is a very important metric of evaluating profitability in the oil and gas sector. Naturally, higher the GRM, the more profitable the refinery. So there you go, you have the dashboard of GRM comparison in the front of you. We have used a Singapore benchmark GRM, which is the industry practice for comparing the gross refining margins with Indian refiners. Now you can see this horizontal bar graph. This horizontal bar graph has been created using Plotly. And you can see a small little logo of each company which is appearing in the horizontal bar graph. Now this has been made possible through base 64 encode option through Python, whereby it fetches the company logos from an independent folder and plots those logos on a horizontal bar graph. Now, this actually enhances the appeal of the dashboard, and it makes interpretation of dashboard a cakewalk. At a single site, a user can quickly understand which bar relates to which company. Isn't this beautiful? Let's quickly go to the third radio button. So third radio button is about a pie chart. This pie chart tells us about the finished products consumed and the consumption trend of the petroleum products in India. You can see that the high-speed diesel HSD is having a major portion, and MS, that is motor spirit, which is technical name for petrol, is the second largest. So India is a diesel heavy economy. So diesel and petrol are the top two products even today in terms of the petroleum products consumed. I have given an option of selecting financial year, a drop down for financial year, which will fetch the last almost 7 to 8 years of data at a click of a button. Let's quickly head to the most appealing or probably the most innovative feature of this dashboard, that is the petrol price simulator. Let me launch the dashboard. So there you go. I have the petrol price simulator in front of you. Now here, what I have to do is I have to put a hypothetical value of crude and certain other parameters of the retail sales price and press compute RSP. If you see, currently the counter of petrol price per liter is set to 0.00. So let me assume that the current crude oil price per barrel is $70. The central excise duties, I'll keep it at 24 rupees. And with remaining other parameters auto populated, I am pressing compute RSP. So you can see the magic happening. It has given the petrol price per liter 108 rupees. Now this display of petrol price simulator, the LED display, has been created through PyCharm and Pillow. Once again, we can see the logo of Indian Oil and a beautiful backdrop of a refinery plant, which enhances the attractiveness of the dashboard. This petrol price simulator is very much useful in times of uncertainty that we live today. So tomorrow, if Trump attacks Iran or if Donald Trump attacks China, you can see crude go up to $200 per barrel. And this petrol price simulator can then predict what will be the petrol price. So just for the sake of curiosity, let me put the per barrel rate as $250 per barrel, keeping all other parameters constant. I will press on compute RSP and you can see the petrol price per liter changing. So there you go, 213 rupees per liter. Similar to petrol price, I have also created a diesel price simulator. The functionality is exactly the same. You input the per barrel rate of crude and you get the diesel price. So I'll just show you by clicking the compute RSP. There you go. So this is one of the most appealing or fantastic feature of this product, which is a what if analysis which the managements can use to predict the price per liter of the two most popular and widely consumed products in India. Hello guys, let's quickly head over to the next group of dashboards, which is related to crude and LNG. I would request the viewers to view this video at 1.5x or 2x depending on their requirement, because at times my speed of narration or speed of articulation might be a bit slow and patience testing. So in the interest of time, you can view this video at 2x speed if required. Let's quickly head to the next portion of the dashboards. So I've clicked on the tile of analytics dashboard for crude and LNG. The Streamlit browser is loading the dashboard. Now, if you notice, the background or the wallpaper of this dashboard has changed. Earlier, the background was a refinery crude distillation unit. Now it is a beautiful oil rig set on a backdrop of a seashore. Let me quickly go through and launch the dashboard. So we have a dashboard menu in which the first dashboard is the city gas distribution market share. There you go, the dashboard has appeared. Now this is a horizontal bar graph which shows the market leadership of city gas distribution companies in terms of the total number of piped natural gas connections in India. You can see that I have plotted the company logo using a combination of Plotly, Pillow and base 64 encoding using Python to give that look and feel to the dashboard and ensure easy interpretation. Now let's quickly head on to the next dashboard, which is for the state-wise distribution of CNG pumps. There you go, the dashboard has loaded. So once again, this is GeoJSON, in which the data from Open Government Database Portal has been extracted and plotted state-wise on the map of country India. Let us view this dashboard with the full screen option. The full screen option enhances the look and feel and appeal of this dashboard. If you take the mouse on the mouse over for each state, it will show the count of CNG pumps that are there in each state. You can see Uttar Pradesh and Maharashtra leading the way with more than 1,000 pumps of CNG. And if you take the mouse over on Jammu and Kashmir or Ladakh, the count appears 0. So this is GeoJSON at its best, making the dashboard interactive and very palatable for the end user. Considering the paucity of time, I will choose not to go through each and every radio button. However, there are many colorful dashboards which have been designed using Plotly, Pillow, and many such Python libraries. So one of them is the LNG import volume analysis graph. If you notice, there is a trend line which shows the monthly volumes of liquefied natural gas imports that India has done. This data is being fetched from the government data portal and plotted into colorful graphs for the end user. So quickly, without any further ado, let us head to the reporting layer. The reporting layer is basically a crisp view of the existing information which we have in data warehouse presented in a line item format. Once again, this is a Streamlit browser with a fresh new image of an oil rig. Let me quickly show you by launching one report. So this is the report of crude processed. If you notice, I have given financial year, refinery name and city as the filters or the input parameters. We have summary metrics which provide a view of how much crude has been processed by the refineries, the average capacity utilization, and the number of refineries which have been analyzed. If you see, if I modify the financial year from 2012-13 to 2022-23, the summary metrics data gets automatically upgraded. There you go. So the capacity utilization has reached 93% and the quantity of crude processed has also changed. The line item wise data is available for user, and we have also given some key insights which shows the overutilized refineries and underutilized refineries in India. We have also given the option of extracting data via download of CSV report, CSV file. Similarly, we have reports for GRM analysis, as well as we have reports for the petroleum retail outlet statistics, that is the geographical distribution of petrol pumps in India. So if you see, Python code has provided, the Google Antigravity has provided this commentary of top 5 states having the maximum number of petrol pumps and bottom 5 states of maximum number of petrol pumps. Now this is something which I had not mentioned directly in the prompt, but it is sheer creativity of Google Gemini Pro to provide such kind of commentary and insightful reporting. So guys, I would once again urge to the viewers to watch this video at 1.5x or 2x speed as per their requirement, because the length of the video is substantial. So let me deal with an important question which any critic would ask. Where is the AI in this product? So you can say, Mr. Swapnil, you are dishing out such long videos, but where is the AI in your Capstone project? My counter question to that critic would be, where is the human involvement? Apart from the prompts and the vibe coding, where is the human involvement? So this brings me to one important tweet that was done few months earlier. The tweet is, so let me quote Mr. Andrew Karpathy here. He said, the hottest new programming language is English. Just take a moment and take a pause and try to absorb this tweet, which has been done by one of the leading voices in AI. Now, this gentleman is the right hand of Elon Musk. So applying this to my Capstone, let me tell you, each and every bar graph, pie chart, and the column charts, as well as the maps that I have shown to you guys, have been generated by Antigravity IDE using Google Gemini Pro as the brain. So for instance, just look at the petrol price simulator, the LED display, and the revolving of digits like slot machine. This is the creativity which AI has applied, and something which even a human developer may not have thought of. What I have done is I have only given refined prompts and ensured iterations happen till a satisfactory minimum viable product is reached. Now this Capstone project has been developed with zero involvement of a Python coder or any UI UX expert, which in itself is a testimony that Python code can be used with integrated development environments to do miracles. So this is nothing but AI. My definition of artificial intelligence is any intelligence which is embedded outside human brain is called artificial intelligence. There is artificial intelligence in this product because a human brain takes at least 10 minutes to perform what if analysis on the forecasted price of petrol given a certain level of crude oil price. But this product can produce the same result in few seconds. The artistic selection of landing page background as well as the accurate plotting of points on country India map using GeoJSON all showcase the prowess of AI. So to summarize, we have used Python coding along with various Python libraries like Plotly, GeoPandas, GeoJSON, Pillow, Streamlit, PyCharm, and many others to produce a data visualization tool which can do wonders. So guys, here we are to the final leg, the part 4 of this capstone project video. So coming to my final part of capstone presentation, let me explain you how does this capstone project link with the modules of AICA Level 2 and the learning outcomes that we had in AICA Level 2. Let me take you through the slide which is there in the front of your screen, where I have mapped the modules with the learning outcomes. So first, let me tell you the modules that were covered, naming few of them, like essentials of Python. We had computer vision, we had web scraping and API integration. We also had design thinking. So all these modules were covered by our esteemed faculties. So as per my opinion, I have applied the working knowledge of at least 4 modules in this capstone project. For example, module 1, prompt engineering. So in prompt engineering, I used the working knowledge when I drafted the to the point and well organized prompts for Antigravity using Gemini Pro. Eventually, I experienced that Gemini Pro adjusted itself to my prompting style and drafting, and it started proactively addressing my messages with holistic interpretation. So module 3, essentials of Python, which was taught. So I touched upon this module and applied it when I made Antigravity IDE to write the code in Python and to do fine tuning of the code as iterations happened one after another. Next is module 4, web scraping and API integration. I used the learning outcomes of this module for building an API data manager and pulling data successfully from open government data platform, which provided me with the valuable data feed for my product. Let me give you an analogy. Data is like blood for a dashboard. The way a purified and fresh blood ensures healthy body, a purified and fresh data from OGD portal will ensure a healthy petroleum dashboard. Finally, module 5, design thinking. So in design thinking, I have applied the process of design thinking to define prompt, to ideate with artificial intelligence, to build prototype, and to do testing. The iterations. It gave me immense satisfaction to see the creativity of Google Gemini Pro unfolding as I did iterations and pushed Gemini Pro higher by applying the design thinking principles. I think I have done justice to whatever I have learned in AICA Level 2. With this, I conclude my capstone video. I thank my viewers for giving a patient hearing to this very, very long video. I vow to continue on this AI learning journey relentlessly and hold high the flag of ICAI. I thank one and all for giving me a patient hearing, and special thanks to the faculties of AICA course, Mr. Dhaval Kodilkar, Mr. Bhavin Goklani, Mr. Prabhav Agarwala and Mr. Harpreet Singh for enriching us with insights. Thank you. This is CA Swapnil Rege signing off.